Hello, welcome to the section Analyzing Policy Behavior. In this section, we'll learn how to query the SE Linux policy in depth and use a multitude of tools to query process transitions. You'll also be able to analyze information flows. We'll end the section with a few smaller analysis tools, including one that shows the differences between two policy files. Now we move on to the first video of this section that deals with single-step analysis. In this video, we'll use different SE Linux policy files and display policy object information. Also, we'll learn to query allow rules, type transition rules, other type rules, and role-related rules. At the end, we'll see how to browse with a poll. Utilities such as SE-Info and SE-Search are able to assist users in performing single-step analysis. They either provide immediate information about an SE Linux object or are capable of querying direct SE Linux rules. So, let's see how to use different SE Linux policy files. The SE-Info and SE-Search utilities can do their job for the currently loaded policy or for a selected policy file. The latter allows developers to query SE Linux policies of systems they do not have direct access to or for which direct access is cumbersome. So, as you write and run the SE policy command, you get all the relevant description with respect to the policy being used by you. The main purpose of the SE-Info application is to display SE Linux object information. This information is presented through the types of objects that SE Linux and the SE-Info application supports. Various SE Linux object types are supported, ranging from the well-known types, attributes, roles, and users, to the more specialized FS use declarations or GenFS con statements. Regardless of the object type that the user is interested in, SE-Info has three main modus operandi. In the first mode, it lists the objects of a given type. For this, only the option has to be passed on, without additional information. For instance, to list all object classes available in the policy, you'd use the command SE-Info --class. Here we have 94 object classes. In the second mode, it can confirm or deny the presence of an object's instance. To accomplish this, add the instance name to the command. For instance, to validate whether the memprotect class is available in the policy, use the command SE-Info -xc memprotect. Sadly, if the given instance is not available, it's only shown as part of the output. The return code of the application is the same regardless of whether the instance has been found or not. This makes it less interesting to use in scripts where the use of grep is recommended. So, let's try the SE-Info with grep. Oops, we missed something. We need to add a space within the brackets. Let's do it again. Done. The third mode displays the expanded information about a selected instance. Although not all information objects support an expanded set, most of the common ones do. The expanded information generally shows a list of different instances that are related to the initial query. For instance, for class information, the expanded information displays the supported permissions of this class with our next command, SE-Info --class -xc memprotect. Finally, SE-Info can display all information immediately through the --all option. This will not show the expanded information though. Where the SE-Info application displays information about SE Linux objects, the SE-Search application is used to query SE Linux rules and behavior information between a source and a target resource. We've been using the SE-Search application to query standard allow rules as well as the impact of SE Linux booleans on these allow rules. The SE-Search application allows us to not just query rules based on the rule type, but also filter out those rules that match a given source expression, using or target expression. Now let's move on to learn about querying allow rules. The first set of rules are the allow rules, which provide type enforcement to allow a source domain to take a type of action against a target resource, assuming the resource class matches. Type the command SE-Search --allow -sguest _t-tc group t-cdir. Press enter. It may take some time to load. So here's what you'll get when you run this command. Related to the allow rules are the audit allow rules and don't audit rules. A second set of rules are type transition rules. These show how actions such as creating new files, directories, or even processes result in a change in security context. A very common analysis done here is to see which type transitions occur that result in different domain. Let's type the command search -t-s guest t-c process. In this output, we can see that even the guest domain has a number of rules that allow transitioning into different domains. This kind of analysis will be used later too when we look at domain transition analysis. After the transition rules, there are two other transition-related rules that are a part of the SE Linux policy, but are not enforced through the operation itself, but through an SE Linux-aware application which queries these rules. The first rule is the type change rule, which tells the SE Linux-aware application that when it's asked to relabel a certain resource or target for a given domain or the source, then the relabeling operation should result in the given type. This is used when a resource is created first by another domain, or we could say the parent, after which it's handed over to the source domain. In this case, the parent domain will invoke SE Linux functions to ensure that the generated resource gets the right context. To query it using the SE search application, use the --type_change option. You can observe the output for the guest T user. The second rule is the type member rule, which is used for poly-instantiated resources. Here again, the parent application that initiates the poly-instantiation is SE Linux aware, and will call the necessary SE Linux functions to ensure that the instantiated resource gets the right context. To query it using the SE search application, use the --type_member option. And here's the output for the type member option. The previous set of rules was strictly related to types. However, SE Linux also has rules related to role activities. With the SE search application, we can query which roles are allowed to be accessed from other roles, and when a role transition, such as switching from a user role to the system role, is performed. The --role_allow option shows the allowed rules. Let's use it. And here's what you'll get on running this command. Now, with --role_trans, we can see when an automatic transition takes place. Type SE search --role_trans-s web admr. So you can see that it displays the role transition. Analyzing role transitions and role allow rules helps administrators deduce when roles are powerful or could result in potential security issues. For instance, having the web ADMR role be able to switch to the system R role through the httpd init_rc exec t type might allow that role to invoke actions outside its scope if it has the rights to modify httpd init_rc exec t resources. According to the next query, which we're going to run next, this does not seem to be the case. Let's type the command se search -sweb adm t -t httpd init_rc exec t capital A. Here's the output for this command. However, it's not sufficient to just look at the main user type. A decent analysis would need to include all types that are reachable by the web ADMR role. This in-depth multi-step analysis is a subject of the coming part in this video. So, a decent tool to perform policy analysis is APOL, offered through the SE Tools package. The APOL tool is graphical in nature and allows analysts and administrators to perform a wealth of analytical actions against the SE Linux policy. Let's start APOL by typing APOL in the Fedora terminal. It will open the APOL GUI window. Once started, the first action to take with APOL is to load a target policy. This can be accomplished through the Open Policy button, which you can find in the File menu. Now, to load it, click on Other Locations and select the preferable directories one after the other, as I do it here. And here we have the loaded policy. Here's a generic overview of the loaded policy. Once it's been loaded, select New Analysis to initiate the policy analysis functions from the Workspace option. A number of analysis methods are provided. Let's select Types to find the next screen, allowing us to browse through the available types, or select an attribute to find out which domains are assigned said attribute. We select the ABRT domain, and we apply it. You can check the results in the pane below. Similarly, with TE rules analysis, we can perform the same analysis as with the SE search application. So let's again go to Workspace, select New Analysis, and click on TE rules. Let's give the source type as guest_T and target as cgroup_T. Finally, we apply it. It may take some time to get loaded. And here we have the results with the rule type, source, target, object class, and permissions. In this video, we've learned in-depth single-step analysis. In the next video, we'll explore about domain transition analysis.